Okay, in this problem, our goal is to write an equation for each line. Fortunately, they gave us the y-intercept of each line. So for example, this line right here crosses the y-axis at what? Well, we go 1, 2, 3. That point is 0, 3. Okay, so that means if we write our equation in y equals mx plus b form, well, that means that our slope now is the only thing left we need to figure out because we have the y-intercept, it's 3. So we know the b value in this is going to be 3. And now we're just finding the slope. How would I find the slope? Well, I would travel from one point to another friendly point and record the change in y and change in x from those points. So we already have the y-intercept. If I go down 3 on the y-axis and then over 2 on the x, we have our slope. That means slope is equal to negative 3 over 2 because here we travel down 3, or when y decreases by 3, x increases by 2. And we could have gone the other way, right? We could have started at this point and said when y increases by 3, x decreases by 2. But either way, we get one variable increasing while the other is decreasing, and that is a negative slope. If we put this together, y is now equal to negative 3 halves x plus 3. And all I did there was plug in the values for m and b into our equation, and we're done. For the other lines, we can do the same thing. Let me just get this color here for this line. All right, for this line, we cross over here at this point. That's the y-intercept. This is line 2, I realize now. So the last one was line 3. Now we have line 2. Line 2's y-intercept is what? Well, we go down 1, so that's 0, negative 1, right? So again, using the y equals mx plus b form, we know b equals negative 1. Notice I'm not writing the whole point. Typically, when you write the y-intercept, you just write the y value of the point. Now, we can travel from this point to any other, but I'm going to use this point over here, since we've already kind of visited that point. What's the change in y? Well, now we go up 1, and we increase 2 on the x-axis. So it's up 1 on the y, and over 2 on the x, and slope is y over x, so that's 1 over 2, or 1/2. That means our y value, when our y value increases by 1, our x value increases by 2. And that means the equation of our line is y equals 1/2 x minus 1, or plus negative 1. And now we only have one left to go. I'm going to use a different color here. Let me try orange for this line, right? I can't write in black on the blackboard over here, but now we have this y-intercept for this line, line number 1. And what's that? Well, that's up 2 on the y-axis, so that's 0, 2. And any other point that's easy to read will do. I'll pick this one. This point is 2, 4. Now, our intercept is 2, so again, y equals mx plus b. b is equal to 2. What is our slope? Well, our slope is equal to, if we start at the y-intercept, we go up 2 and then over 2. Notice if I had started at the higher point over here, I would go down 2 and back 2. So essentially, you can think of that as a negative over a negative, or a positive over a positive. Our slope is positive here, and it's 2 over 2, or 1. And you can see that if we just go up 1 over 1, up 1 over 1, and so forth to form and connect the rate of increase on all of the points in this line. And that means we have y equals 1x, right, or just x plus 2. So in this example, we're just using the idea of slope-intercept, right, to write out the equation of a line. We don't have to write it in this form, but it happens to be very useful when we have the slope and intercept at our disposal. Thanks.